For this video, we want to discuss the shape of the graph and how the derivative affects the shape of the graph, what the relationship between the shape and the derivative are. So when we know that the derivative is the slope of the tangent line, so if I look at this portion of the graph here, I can see that all my tangent lines are going uphill. So that means right here, all of those tangent lines have a positive slope. So here, f prime of x is greater than 0. And similarly on this portion of the graph, when I draw my tangent lines, I can see that each of them have positive slope. So here, f prime of x is also greater than 0. And then at these points right here, they have horizontal tangents. And for a horizontal tangent, the slope must be 0. So there, f prime of x is equal to 0. And on this middle portion, right here, when I draw the tangent lines, what I can see is that all of those tangent lines have negative slope. So right there, f prime of x is less than 0. And if I think about how I would describe the shape of this graph, where those tangent lines are going uphill in the orange, where f prime of x is greater than 0, that's where the function is increasing. So we have it's increasing in 2 locations there. And on that middle portion, where I can see the values are decreasing, those y values, I know that my function is decreasing, and see that that corresponds to the derivative being less than 0. So for the portions of the graph where the function is increasing, the derivative is positive. And for the portion of the graph where the function is decreasing, the derivatives are negative. And then here, right there, we have a local max. And I can see, in order to have a local max, it switched from increasing to decreasing. Or in other words, the derivative goes from positive to negative. And then down there, here we have a local min. And that happens where the graph switches from decreasing to increasing. Or in other words, where the derivative goes from negative to positive. Also, the derivative can tell us something about concavity. So on the portion of the graph right here, I can see that my function is concave down. And I can see that because on concave down, it makes a frown. And then over here, my function is concave up. Concave up makes a smile. Like that. And what I can notice here is that when I draw these tangent lines on this portion that is concave down, they have a really steep slope, and then they get more narrow, gets towards 0 here, and then they become negative, and they become more and more negative. So on this concave down portion, I can see that the slopes of those tangent lines are decreasing. So my f prime of x is decreasing here. And then, as we just discovered, when a function is decreasing, its derivative is negative. So therefore, the derivative of the derivative, the second derivative, is less than 0. And that's how I can tell when something is concave down. Now for concave up, when I go over here and I draw my tangent lines, I can see that they are becoming larger and larger numbers. So on this side, where I have a concave up portion of my graph, f prime of x is increasing. And for a function to be increasing, its derivative has to be greater than 0. So the derivative's derivative, which is the second derivative, is greater than 0. So for concavity, concave down corresponds to a second derivative being less than 0, and concave up corresponds to a second derivative being positive. And then we also have a special point right here in purple where it switches concavity, and a switch in concavity corresponds to what is called an inflection point. So if there is a point on the graph where concavity changes, we call that an inflection point.